Well, the objective of this demonstration is to show the row operations in Fortran. So I take the example and I will read the data in a separate file. Okay. So this contains A is 4 minus 1, 1. The coefficient matrix 2, 5, 2, and 1, 2, 4. And the entries of B are 8, 3, 11. They are written in a row. I save this data as any kind of file, so normal text file or any file. I select the option all types, right? So it means the extension is free. I can provide my extension. So I say okay. Say system3.dat, right? So it's a 3x3 system data. So it is saved in the working directory. By the way, it can be saved in any other directory as well. Anywhere on your computer, Fortran is going to find it from its address. The name of the file means its complete address in any directory. So let's write the Fortran program. So program system 3. System 3. It's a linear system. Linear system 3. It's a 3x3 system. And end program linear system 3. And I write here implicit none. I require matrix. So real matrix A of size 3x3. Require a real vector B vector that can store 3 elements. For solution, there should be real X that can store 3 entries. The integers I, J, and whatever. Sometimes I write n row and column. So let's read the data from the file. So we have to first create its ID, its type. So I say unit 15. It's our choice. Then the name of the file, it should be like a character variable. So it is system3.dat. Then I can suggest the status of the file. So this should be an old file. It should be already present in the directory. Our objective is to read the data from this file. So for reading, I will write the structure do I varies from 1 up to 3, right? Because there are 3 rows, but let's make it generic. I say n row equal to 3 and column equal to 3. So the program is going to be a bit generic. N rows, and then right here read statement, read from unit 15 with the default option of separate values, and then A, ij, where j would vary from 1 to n column, right? And there will be the n statement. So if it has been read correctly, then we have read first 3 lines, data from the first 3 lines of the input file. And then we have to read the next data, which is written as 5th line. Blanks are ignored by Fortran, right? So for B values, I can simply write read in from unit 15 with the default option. So if I write B, that is sufficient, right? Or if you want to be very sure, so I can write bj, where j varies from 1 up to 3. So that is the data reading. So let's print it so that we are confirmed we have read the matrix and data properly. So I write do I varies from 1 to n rows, and here I can write statement asterisk comma asterisk. We have not defined any file for printing, so it will be just like the print asterisk statement. Aij, where j varies from 1 up to n column, and undo, and I write here right asterisk comma asterisk and vector b. So it will be printed in a row. So let's save the data. Save the Fortran program. Program linear Fortran file linear system 3.4. It now it looks like a Fortran program with the text in, you can say, nice colors. This is the one I like. D directory cd g77/bin. Now G77 linear system 3.4 minus O linear system 3.exe. Okay, so compilation has been successful. Linear system 3.exe. So the data has been properly read from the data file, right? So B has been identified and A has also been identified. Now, my objective is to apply the row operation. So eliminating below the principal diagonal. So here I'm going to write the code for it, and I write here a title. Eliminate. These lines are to eliminate below the principal diagonal entry A11, right? Below A11 is A21 and A31, right? And we have to apply the row operation. So see how I'm going to apply this thing. I define a variable as the multiplier, real. So I say x multiplier. I have to apply two operations, right? So I write here operation, say, do a varies from 2 to 3. So row operation, I will define first a multiplier. The first multiplier I define x multiplier equal to a1 divided by a11. So one multiplier is a21 and a31, right? So with the first multiplier, it means I'm going to apply the operation on that row and from the first row, right? So the operation is defined as, right here, operation, say, R2 equal to R2 minus x multiplier times R1. I also define the row operation R3 equal to R3 minus x multiplied times R1. So two mathematical operations, they are controlled by the index k. So where k is going to take the positions of the values of 2 and 3, right? So now the multiplier defined. Now in one row, the operation is going to be defined on element by element basis. So I'm going to define the index j for the column column index. So I write here do j varies from 1 up to 3. There are 3 elements in one row. So now the operation. Second row, a the second row elements a k. So a aj equal to a kj minus x multiplier times r 1j. Right. See for this expression. This is the row operation on kth row. So let me write here the generic form. The generic form is rk. On kth row, the operation is rk minus x multiplied times r1. This is the expression that I have written in front of you, right? Behold, don't be sleepy. This is the most important time in learning the matrix calculation. Right. And final undo for k index and for j index. We have limited these indices from 2 to 3, but if you make them generic, that program will definitely work for any size of the matrix, right? But whenever we perform this type of operation on a row, right, we have to accordingly update the column vector b, right? For that case, I write b of k is equal to whole value of b of k minus x multiplied times b1, right? Because the operation was defined on the basis of first row. Please imagine during this time, the calculations we perform in augmented matrix, right? Where the last column is the column b vector. So I have eliminated below a11, right? Let's see the situation of the matrix, and that will be the stopping point of my demonstration. So now I'm going to print the matrix and vector b. So do I varies from 1 up to n row, and write or print both are fine. We are printing on the command window. So j varies from 1 up to n column. And this is undo. So let's print I have a better notation. Not this one. No. Okay, let's work with that. And I write here b of I, right? Printing like an augmented matrix. And here, right, there is comma, there is. Okay, so I have eliminated below the principal diagonal entry 11, A11. So on similar lines, you can eliminate below the other diagonal entries. So let's see the working of the algorithm up to this point. So the our program reads the data from a file, and then it performs it prints the data that has been read, and then it is going to perform the row operation. Compilation. Okay. Do k varies from. Okay, has not been identified. Oh, R1J. Okay. So some typing mistakes have been pointed out by the compiler. So on lines 24 and 30. So let's correct them. X multiplied R should not be there. Yes, it should be A1J, right? And then I have used k somewhere. which was not identified, which was considered strange due to the implicit none statement, right? It has rightfully been compiled, and behold. So 4 minus 1, 1, 0, 5.5, 1.5, 2.25, 3.75. So eliminations have been successfully performed below the diagonal entry A11 below 4, right? So formatting has been disturbed, therefore it means proper formatting should be provided, right? Let's attempt it. So this is the place where we have to provide the formatting. So in the same style, I can write 1x f 7.2 and okay, repeat it 3 times, and then we have one character. So I write A2, and then I have a real value. Okay, let's say 1x and sorry, this is not the place where I have to provide the format. That should be in the printing statement. Printing statement after the vector has been after the row operation has been performed. So it should be somewhere here. Okay. So 2 apostrophes 1x and then f 7.3 and that's it. Well, this 3 should be within the parentheses 3 times this one. Yes, parentheses are balanced. Any other problem of column exceeding? Column exceeding. Yes. 71st column. 72 columns are allowed. The output, just like the augmented matrix. Okay. So hope you will be able to continue writing this type of stuff. So once you make it automated, this type of program will work for any size of the matrix.